Hi all, in this video I'm going to show the new version of my spot welder completely designed by zero. In this video, this video is pretty long, but I appreciate you if you follow all the steps because in my opinion are pretty interesting from several points of view. The discussion points are listed on the left. The first point is the improving freewheeling. In this case, the new board, I decided to increase the reliability, so I decided to put another capacitor in parallel to the MOSFETs. For the same reason, I've added a transient voltage suppressor diode to increase the reliability of the board. The point 3 consists in designing a new copper bar where the MOSFETs are placed for other reason, then I will explain later. I will capture some current transient to show the effectiveness of the new design, and finally I will do some tests with the technique of copper nickel plated strip using a copper sheet of 0.1 millimeter in the middle. In this slide I would like to describe why I decided to design a new board, which is the history behind. At the beginning I bought from AliExpress this board. As soon as I connected the terminals to the battery and I tried to do a spot weld, the board immediately failed. So I bought a new board in YouTube. The Birch board seems to be the best one, but this board has the same issues of the previous one, some electrical mistakes. Some YouTubers put a heat sink here because the MOSFETs get hot during the working because there are the problems in the driver circuit. I changed the driver circuit and added other components on the board to get the solution which works pretty well. And this board is described in my previous video, but also this board had some issues that have been fixed in this version. As discussed in the other video, we have a battery, a board, and a spot welder pen. The circuit has this equivalent circuit where the line 1 is represented by the cables between the battery and the board, and the line 2 is represented by the cables connecting the board to the spot welder pen. And this switch is represented by the two terminals of the electrodes. Here the resistance is neglected, but there is the series resistance of the cables and the resistance of the electrodes. At the moment has not been represented. The main variation from the previous version, I've applied the spot welder trigger enable this other switch. Why? Because in the previous board I had to wait that the pulse across the electrodes was active So this board, this birch board, has continuous pulses, and the LED is activated when the pulses is active. But you have to wait the exact instant when the pulse is arriving here. This is a problem when you go in hurry, or you are not, you don't care of the LED. If you disconnect the pen while the pulse is arriving, you can create some over voltages, you can damage the board. Instead of waiting it, I decided to enable this series of pulses using this switch. Enables means also you cut the wave at the output, or you enable it, but this pulse is always with a very short rising leading edge, because you are working in the digital form of the pulse. So you don't have, for example, some rebounds caused by a manual switch, or some slow rising edge or slow falling edge, which will cause a failure of the MOSFETs. Another feature added consists in adding this new inductance, which entails a better filtration of the pulses coming from the power supply. So these pulses increasing on voltage is limited, and the integrated circuits are saved from extra voltages. Then little capacitance here and here from 100 nanofarads are needed, because they have a low electric series resistance. They facilitate the work of this big capacitance here. Another capacitor is added across the MOSFET driver. This capacitor is a ceramic capacitor, 10 microfarad. I put 22 microfarad because I had this available at the moment. And this additional capacitance enable the driver to provide a better pulse of current in the several MOSFETs, because we have 8 MOSFETs in parallel, each one with a big gate capacitance. So the current flowing instantaneously through the gates is quite big. So an additional capacitance can provide this reservoir of additional energy. Now we go to the first point: improve the freewheeling. As I told in the past video, across the MOSFET and between the drain and the source there is a parasitic capacitance. We increase this capacitance because at parity of energy stored in the inductance, if we increase C, we decrease the voltage overload here across the MOSFETs, and we prevent the MOSFET to be damaged. Here is shown 1 microfarad, but I used 4.7 microfarad in polyester, a polyester capacitor. But 4.7 microfarad, in my opinion, is too small, and then the capacitor, a ceramic capacitor, is better from the electric point of view, because they have a low ESR. So I decided to buy this SMD capacitor of 22 microfarad and 50 volts. I put 9 ceramic capacitor in parallel to get lower ESR,